Okay, so up until now we have considered the potential of a dipole, and what we're going to do in this lesson is consider the electric field of a dipole. And to do this we're going to choose the coordinates so that the dipole is going to lie at the origin and it's going to point in the z direction. Okay, so I'm going to draw up my three axes, x, y, and z. The dipole will lie at the origin, point in the z direction, so the dipole can be written as p times z hat. And we're going to do this in spherical coordinates. So remember the distance from the origin to some point P is given by r. The angle down from the z-axis to that point is given by theta. And the azimuthal angle is given by phi. And that's that angle around from the x-axis. Now of course we have our unit vectors, which is r hat, and these are pointing in the direction of increase, theta hat and phi hat. Okay, so I'm going to write up the potential for a dipole. So the potential for a dipole depends on r and it depends on theta, and it's equal to r hat dot p divided by 4 pi epsilon naught r squared, or I can write it out in terms of p and cos. So you have p cos theta divided by 4 pi epsilon naught r squared. And we're going to use this in order to determine the electric field. So to determine the electric field, we're going to do it for each of these directions. So in the r direction, the theta direction, and the phi direction. I'm going to do this by taking their partial derivatives. So if I move over here, we'll do it for r first of all. So electric field in the r direction will be minus dv over the r, which will equal 2p cos theta divided by 4 pi epsilon naught r cubed. Okay, so that's the electric field in the r direction. In the theta direction, be minus 1 over r by dv d theta, which will be equal to p sine theta divided by 4 pi epsilon naught r cubed. And in the phi direction, it will be minus 1 over r sine theta dv d phi, which is going to be equal to 0. Okay, so you can see that our electric field will be dependent on the r and the theta. So let's just write this out in full. So our electric field E, which depends on r and theta, can be written as P divided by 4 pi epsilon naught by 2 cos theta theta r hat plus sine theta theta hat. Okay, so this is the electric field for our dipole. And what's missing here is an r cubed term. Okay, so what we can see is for a point charge, the electric field is going to go as 1 over r squared, but for a dipole, it's going to go as 1 over r cubed. For a quadrupole, it's going to go as 1 over r to the 4, and octupole 1 over r to the 5.